Ahoy, mateys. We're jumping into 5.5, which is factoring expressions, also known as undistributing. It is going backwards from distributing. Okay, let's jump into it. Bam, here we go. So if you're going, is not the right slide. Oh, first we're going to practice simplifying expressions just to make sure that you're understanding what we've done so far. If you missed these ones, I would suggest getting some help because this is super important when you're simplifying expressions. So for A here, if you simplify A, what do you get? All right, let's go through that one. So you can combine the 3x and the 2x. They're using the properties, which you should use. So commutative property they're using with the middle terms to switch them around. And then you got the 3x and the 2x next to each other, and you have the 9 and the 5 next to each other. And then the 3x and the 2x, you can combine together. And you get 5x, and then the 9 minus 5 is 4, so you get 5x plus 4. Yay! All right, for B here, what do you get when you simplify y plus y plus y? Don't forget there's an invisible 1 in front of those y's, and that's the multiplication property of 1. You can show them there by just multiplying by 1. And then when you add them together, you get 3 y's. Yay, there we go. Oh, and we're jumping into C already. I clicked one too many times. So for C, you're going to first have to distribute that 2. You're going to want to do this one on paper. Okay, so do C on paper and then figure out what it is when you're all said and done and it's all simplified. Okay, so you're distributing the 2 to the Z. You're also distributing the 2 to the minus 5y, and that gives you the 7z still in front, plus 2z minus 2 times 5y, which is 10y. And then you can put together the 7z and the 2z, and that adds up to 9z. So it's 9z minus 10y. You can't combine those because z's and y's don't go together. Okay, so now we've reviewed that. We're going to jump into factoring. Here's how it works. So to factor 18 plus 38, we're not adding 18 and 38, we're factoring. So factoring is undistributing. And this normally uses the greatest common factor, but you can use any factor. But they're telling us to use the greatest common factor of 18 and 30. So let's jog your memory, check your notes maybe. What is the greatest common factor of 18 and 30? If you don't know, one way to look is to list out all the factors of 18. There they are. And then list out all the factors of 30. You can also do this with a factor tree is another great way to go. Or this can be done with a factor rainbow. The greatest common factor is the biggest factor, which they have in common. In this case, it's 6. So 6 is the greatest common factor. Okay, so what you're going to do is undistribute, which means 6 will be the term on the outside of the parentheses. And then you got to figure out what do you have to multiply by 6 to get 18 and 30. So 6 times 3 is 18. 6 times 5 is 30. So if you are factoring, that's our answer right here is 6 parentheses 3 plus 5. Again, you're not actually multiplying it out. You are factoring, you're undistributing. So take a look at that, make sure it makes sense what you're doing when you're undistributing. Okay, now we're going to move on to the next example. So factor this using the GCF. So first, what is the GCF of 20 and 12? Okay, hopefully you got 4, because 4 is the biggest number that goes into both 20 and 12. So if you list out all the factors, you'll see 4 is the biggest one they have in common. So what do you think will be the factored form of 20 minus 12 using 4 as the GCF? Okay, let's see if you got that one. Okay, so the 4 is going to be on the outside of the parentheses, and then it's going to have a 5 minus 3 inside because 4 times 5 is the 20, and 4 times 3 is the 12, and it's subtraction, so we got to have a minus in the middle. So again, this is undistributing. It's like going backwards of distributing. So again, look this over, make sure it makes sense. Maybe jot some notes down. This is a great example to have in your notes. And now here's how it works when they're not all just numbers. Sometimes you'll be factoring things that have exponents and they'll have variables and they'll have other things. So we're going to go over this example right here. So if we're going to factor 3x plus 42, we got to figure what is the biggest number that goes into 3 and 42? It's 3. 3 goes into 42. So then 3 is going to be outside the parentheses. Let me scroll down here. So 3 will be outside the parentheses, and then inside the parentheses will be x plus 14, because 3 times x is 3x. 3 times 14 is 42. Okay, so let me see if I can highlight. Oh, I can a little bit. So look over everything I just highlighted there in blue and make sure that makes sense. And you may want to add that to your notes as well. And then we're going to go over this next example. So you're going to factor out 63z minus 27y. So what you want to do is find the GCF of 63 and 27. So what is the GCF, the greatest common factor of 63 and 27? Okay, so if you break it down into prime factors, you'll see that they have 3 and 3 in common, which is 9. 3 times 3 is 9. So 9 is the GCF. So 9 is going to go on the outside of the parentheses. So if we're going to factor, let me highlight this thing now. So we're going to factor 63z minus 27y, and 9 is going to go outside the parentheses. What's going to be left inside the parentheses? Well, basically, what's it going to look like when we factor it? All right, let's see how you did. So the 9 goes on the outside, and then in order to get 63z, you have to do 9 times 7z. And then in order to get this minus 27y, you got to do 9 times minus 3y. So that is the factored form, the thing I just highlighted there in blue. Okay, again, that's another great example to add to your notes. That is factoring. All right, I'm going to leave it there. If you have questions while you are factoring, again, it's undistributing. It's going backwards from distributed property. If you have any questions while you're working through the big ideas, let me know, or see Ms. Rude, or send me an email or Flipgrid. All right, good luck. I will see you in class. Arr!